Now, when you're doing compound interest, make sure you know how to present your question and also pattern recognize. That's the main thing, okay? So you start off with a fund start at 6,000, compound the interest of 3%. It's added to the fund at the end of each year. Okay, end of each year. If withdrawal of K are made at the beginning of each subsequent years, so that the amount in the fund beginning of N plus 1 year is this amount. Okay, so what we're going to do is just write down at the start and at the end. Okay, so remember to do that. So you start of a year. Pattern recognition. You don't use don't go and key in calculator, like, okay, don't go and compute. You need to be able to see. So the first year, at the start and at the end. So the start is 6,000, right? At the end, there will be a 3% compound interest. Oh, that's a lot. Actually, yeah, usually bank don't give compound interest on, they just give simple interest. 6,000, 0. So this will be multiplied by 1.03, and then we issue that. You know what? 1.03. Yeah. Then the subsequent year, what happened? You want to withdraw. Yes, so 6,000 times 1.03 minus K. You don't compute using GC. So you are tempted to compute using GC, don't, because what you need now is pattern recognize. Okay, so don't do that. Okay, that's very difficult to see. Okay. Then subsequently, so this one here is minus K. Then this one here is multiply 1.03. So when you multiply, this will be 6,000, 1.03 square minus K, 1.03. Right? Then similarly for the third one, 6,000, 1.03 square minus K, 1.03 minus K. Then you just keep repeating until you can see the pattern. Okay. I strongly agree. Suggest you to go and practice bank interest question. They say they want the beginning of the year, right? Pattern recognition. So you do. Okay, you can sort of write down the next one for this one here. 6,000, 1.03 cube minus K, 1.03 square minus K, 1.03 minus K. Okay. Then the fifth one, what will you look like right now? If you can't see the pattern, just write it down. It's fine. It's GP and general recognition. So once done here, so look at the pattern recognition. This part here, you need it to be N plus 1 years, right? So this is N plus 1. N plus 1 year. Okay. Yeah. So it's how? So this is pretty okay. There are two parts here. There are two parts. Usually there are two parts. This kind of when they compound and then withdraw every subsequent year. One part is normal pattern recognition at the front. Behind here is GP. Okay. So the one behind here is what? 6,000. 1.03 to the power of N. N plus 1 minus 1. Okay. And then we just N. Correct. Okay. So because now when you see pattern recognition, this is what you do. When this is 1, when this is 2, this is 1, when this is 3, this is 2, this is 4, this is 3, this is 5, this is 4. Okay. So if this is N plus 1, you will know that this is 6,000, 1.03 N plus 1 minus 1, which is actually just N. Okay. Now the one behind here, what you do, these are sum of GP, right? The one behind sum of GP. This case here, factorize the negative out, factorize the negative out, factorize the negative out. All these GP here, what's the first term? Okay, the R is 103. Okay, this one here is S what? This is sum of how many term? One term. This is sum of? This is sum of? This is sum of? 4. Okay, good. So the M. So you're right. So when this is 5, this is 4. This is 4, this is 3. So this one you expect it to be minus if n plus 1. Yeah, Sn. Okay, you want Sn because you want the n plus 1 here, not the n here. Okay, so this is minus Sn. Please know how to do this. Then this will be 6,000 minus of A 1.03 n minus 1. Okay, I don't think you need. So 1 divided by 0.03, 100 over 3. Is that it? Oh, they want us to factorize the 100 over 3 out. Quite funny, but okay. Alright. Why? What's the point? Okay, 3. This would just be so I factorize it out. Go. Okay. It is given that k is 400, meaning every year he withdrew $400, and then at the beginning of each year, for the first time, will the amount in the fund be less than 1,000? Will it be less than 1,000? So we check lah. Just substitute it in. Use the amount. K is 400. Yeah. At the beginning, which year will the amount of fund be less than 1,000? So this is minus 400 plus 400 less than 1,000. At the beginning of which year for the first time? Okay, so we need to find n, right? This is n plus 1 year, the amount at the start of n plus 1 year. This of n plus 1 year. Okay, you want to find n, so what you need just solve this. Key in calculator, 1,000. I'm just gonna bring the 3 and 100 over, so this is 400 to yeah, and 1,000 times 3 over 100. Then this is 1,000 30. Oh yes, minus 100. 370, right? Yeah, so 1.03 and flip the sign. $370, right? Negative 370. Negative 370, then this will be ln. Then divide. Okay. Least n is 18, right? Okay, which year? At the start of which year? Beginning of which year? At the beginning of n plus 1 year, which is 19 here. Okay, because what we solved just now was in terms of n plus 1 year, right? The n plus 1 there is annoying, I know. So just make sure you're okay with that. The next part is fully withdrawn at the beginning of 16th year. So the beginning of n plus 1 equals to 16, so n is 15. Okay, least value okay. So this is pretty okay. Fully withdrawn means in the bank account, fully withdrawn. How much will you see in your bank account? Yeah, 0. N equals 16. The whole thing fully withdrawn. If your fully withdrawn is not 0 in your bank account, let me know. I don't mind taking over your bank account. Okay. 003. 15. Oh, 15. Sorry? Yeah, 0. So you just this 0 lah. So yeah. So this is 180. There you go. Sorry. Then you just yeah. It. Oh, find the least value. Okay, can. Sorry, you need the least value. Okay. Yeah. If least value means you have slightly above more than 0. Just make sure that this is 0 lah. The inequality should be. You will just want it to be the last withdrawal amount, so it should be more than 0. Then this will be least value. Okay, so it's at most. 1.